I've seen many familiar names and faces, and also many new people as well. Great to see all of you. Okay, I think we should get started. Now it should be good afternoon, everyone. My name is Rupeng An. I'm associate professor at the Brown School and Division of Computational and Data Sciences. Now we are hosting a series of AI workshops, and this is the second one devoted to AI detection tools. Great to see everyone here. Let me share my presentation slides. Again, the video recordings as well as the presentation slides will be available for all of you who have registered for the event. We will send a separate email for the link to the recording and the presentation. So let me share my screen and enlarge this. Okay, great. So today we are going to talk about a really exciting topic on how we can navigate AI detection tools for academic integrity. First, I want to acknowledge the many people's efforts to make this happen. Particularly, I want to emphasize that Yu Yang, who is my PhD student, she is also the audience here. She designed the presentation slides and really great devotion to this project. And I would also thank Jennifer Smith, the Vice Provost for Education, Sally Wu and Kelly Weir from the CTL, as well as Michael and Eric for your fantastic support to make this happen. Okay, so I believe that all of us have known know something about AI detection tools because now it is everywhere. And many people, both students as well faculty, start using those AI writing detection tools to assess the authenticity of academic submissions, no matter homework assignments or paper submission, abstract submission, etc. Right? So the purpose of those AI detection tools, they are designed to identify text generated by artificial intelligence, most likely generative AI, aiding educators in maintaining academic standards. So that is the purpose of those tools, but not only purpose. There are other purposes as well. We are going to talk about them later. So the main functionality of those tools are to utilize advanced algorithms that we are going to talk about. There are many algorithms that are available to analyze writing patterns, syntax, and linguistic features, and then giving an estimate about to what extent, to what probability that the text are written by a human being or by AI algorithms. So the goal is to differentiate between human-authored and AI-generated content to safeguard academic integrity. So here we listed a number of those tools, but by no means they are exhaustive, right? There are many other tools, probably hundreds of tools available there. But what are listed here are probably the most popular ones, such as Scribr, Turnitin, Grammarly, GPT-0, CopyLeaks, Crossplug, Originality AI, AI Writer, and the AI text classifier published by OpenAI. So there are many other tools available there. And you probably realize that not all of those tools, their primary functions are about AI writing detection. Right? For example, Grammarly is a tool mainly used for detecting and correcting grammatical mistakes. And Turnitin is mainly a tool used to detect plagiarism. Right? And we will talk about the differences and nuances of tools as we go. Again, if you have any questions, or comments, feel free to post on the chat, and I'll come back to you by the end of the presentation. I'll make sure to leave ample space, ample time for us to go over your questions, comments, and concerns. Okay. So now first let's talk about how we can manually detect the AI-generated writing, because this is very intuitive, right? Giving us a lot of idea of how we can develop AI tools to automate the detection of AI-generated writing. One, we want to look at autonomous text, right? Because the AI-generated texts are usually repetitive, especially if we use the previous large language models such as GPT-1 and 2 and 3, and other earlier large language models. They tend to generate repetitive sentence structures because the algorithm design. Second is we look at predictable language. For example, generic words choices without unique expressions. As a human, we also look at, for example, politeness, right? For example, AI like ChatGPT is often generating very polite and very formal language, unlike human beings, which are usually more casual. And hedging phrases. For example, you may look for a lack of bold original statements. And for AI-generated text, they usually overuse generic hedging phrases. For example, it is important to note that X is widely regarded as, or X is considered, and some might say that. So a lot of hedging phrases at the beginning of the sentences. You may also look at voice inconsistency for the AI-generated text. For example, if you know the usual writing style and the voice of a person whose writing you are tracking, maybe a student, then you can usually see when they submit something that read very differently from how they normally write, right? So a clear deviation from their writing habits or writing style would be an indication that the text is generated by AI rather than the person. And of course, we all know incorrect citations and large language models are often criticized for providing incorrect or non-existent citations. And actually, we have a talk that's coming. The next talk on the AI workshop, we are going to cover a variety of strategies and practical implementations on how to address hallucination for large language models, of course, including incorrect citations. So keep tuned, and we'll come back with that topic. And finally, logical errors. The AI-generated text sometimes have contradictions or implausible statements that if we pay attention to, we can differentiate that from human-written text. And now let's dive into the AI algorithms, right? How AI tools are able to identify AI-generated text. First, let's talk about Perplexity, which is a very commonly used statistics concept that are used to measure predictability of the text. So a AI written text usually have low perplexity. So perplexity indicates creativity and human writing usually have high perplexity, denoting high creativity, but lack of inconsistency. On the other hand, the AI-generated text usually have a lower perplexity score, suggesting AI generation due to the predictable nature. In a nutshell, the AI-generated text aim for low perplexity, producing content that is logical, that is very smooth, that is coherent, but also very predictable and lack of creativity. On the other hand, human-created text exhibit high perplexity with diverse language choices, but occasionally errors. And Scribner and GPT-0, they mainly adopt perplexity as their statistic in identifying AI-generated text. So that may give you some examples. Here, if we start with a sentence, I couldn't get to sleep last, then let's take a look of the language that have a high or low perplexity score. For example, if you complete the sentence as I couldn't get to sleep last night, right? So night is the new word added to the last. And then this sentence usually have a pretty low perplexity score because it's very easy to predict the next word, right? Remember all the causal language models, they try to predict the next word and use the one with the highest probability. So for text completion, night is a very predictable word, so that the sentence tend to have a low perplexity. Consider the next example. I couldn't get to sleep last time. I drank coffee in the evening. So this is a little less expected compared to night, but I would say still predictable. So the perplexity score likely to be within low to medium. So it's less likely, but make grammatical and logical sense, right? And then consider the next example. I couldn't get to sleep last summer on many nights because of how hot it was at that time. I would say this is a little harder to predict, right? So the perplexity score tend to be in the medium. The sentence is still coherent, but the structure is unusual and also long-winded. And finally, the sentence, I couldn't get to sleep last, pleased to meet you, right? So this is absolutely incoherent and grammatically incorrect and probably not logical as well. So this sentence would have a very high perplexity score. So using Perplexity, AI may detect AI-generated text. But besides perplexity, there's another very important statistic called burstiness, which is often used by AI detection tools as well. For example, Scriber and GPT-0. So the burstiness measures sentence structure and length variation. So low burstiness suggests AI authorship, as AI models often opt for the most likely, hence predictable sentence structures. So the difference between burstiness and the perplexity is that burstiness consider the sentence structure rather than at the word level. Okay. So we would say that AI-generated text usually show low burstiness with kind of uniform sentence length. For example, every sentence is about 10 to 20 words, and conventional structures, which is monotonous writing that you can detect using AI tools. On the other hand, human-created text usually exhibits high burstiness, reflecting a wide range of sentence structures and lengths, signaling both creative and diverse writing styles. So let's take a look of an example. So a sentence with a high burstiness may look like this. At times, you might see a sentence that is short, abrupt, then suddenly there emerges a complex and winding sentence, one that weaves through commas, dashes, and semicolons, a sentence that takes you on a journey through vivid imaginary and elaborate ideas, winding up in unexpected places and pausing only briefly before the next brief statement. So it goes. Right. So the structure of those sentences tend to be very diverse, right? With short sentences and very long sentences in between. On the other hand, a paragraph with low burstiness look like this. Every sentence in this text is uniform. The sentences are simple. They are brief. They follow a predictable pattern. There's little variation in length or complexity. The content is straightforward. This consistency continues throughout the paragraph. It maintains a steady rhythm. It's easy to follow. Right? As you can see here, the sentences are very plain with uniform length and are highly predictable. Right? So from here, probably it may demystify a lot of misperceptions about how AI tools are identifying AI-generated text, right? They are mainly utilizing those statistics, and hopefully they are very intuitive to us as well. And the third way the AI tools identify AI-generated text is through modeling, right? As we can guess, a simple example would be how we filter out our spam email, right? Basically, we build a model and train the model with a number of spam email as well as regular email, and then we label them, right? So later on, the model will learn the pattern of the spam email in contrast with the regular email and be able to label and be able to predict the true label of the email, whether the spam or a regular email. And very same idea applied here. For example, the OpenAI text classifier, the clause plag, and the originality AI, all of them adopted a language model perspective. They train their unique large language models to classify AI written text and human written text. So on the right-hand side, we illustrate the process. First, we need to collect abundance of data, basically pairs of human written and AI written text. And then we divide each text into a prompt and a response so that we can get a variety of AI generated text to augment our data set, right? So for example, you may use a human written text and then ask AI to write a similar text using the same prompt. And then, after we get abundance of probably tens of thousands, if not millions of pairs of text written by human being as well as by AI, and then we can train a supervised classifier. Basically, supervised means that we have hand annotated data set with both AI generated and human generated text with labels. Labeled as either human written or AI written. And then we use those pairs of data to train or fine-tune a large language model. And then, of course, after this model is trained or fine-tuned, the model is able to make a prediction on to what extent a newly unseen text is generated by AI or by human being. Right? And the model is also able to provide you some kind of confidence threshold so that you know how likely the text is generated by AI or by a human being. And besides the perplexity, the burstiness, and large language models, the fourth way that we can identify AI-generated text is through text segments. So the idea is pretty simple. The algorithm breaks down submissions into overlapped text segments to analyze contextually. Okay? For example, Turnitin used the text segments algorithm. So the AI detection process is to evaluate segments against the model to estimate AI authorship, to what extent the text is generated by AI. And of course, it's adopt a scoring system to calculate the average AI score for the entire document's likelihood of being AI written. The underlying model used is transformer models. Actually, most of the large language models today are based on transformer architecture. So it will be able to give you the statistical likelihood of the word sequences to what extent is generated by AI. Here is an example. For example, how the Turnitin can segment a sentence into different pieces and analyze them contextually and then put them together. For instance, an essay start with artificial intelligence has revolutionized the way we interact with technology. Its impact on society is profound, offering new opportunities and challenges. And then the tool might first analyze the sentence segment. For example, artificial intelligence has revolutionized the way we interact with technology. And then is going to move to the next segment and analyze that segment. For example, the way we interact with technology, its impact on society is profound. You notice that they are overlapping, right? Because this is the way that the algorithm works by considering overlapping structures. And then the third sentence probably would be impact on society is profound, offering new opportunities and challenges, right? And then for every segment,
No food should go into
use
nose
AI tools to identify the extent to which the text is generated by AI. Then it integrate, they aggregate all the scores together, taking an average, and then the average would indicate the global evaluation on the entire syntax. So there are many other AI writing detection tools, and many of them are free. So here we give you the link to many of the free AI detection tools for you to examine and test and play with. For example, no Scribble, no GPT-0, copy leaks, Hive moderation, content at scale, and zero GPT. So feel free to play with those tools to get understanding of how those algorithm works, and also you may test to what extent they are accurate. Okay. I see some people are raising hands. No, I appreciate that. So if you have any questions, please feel free to provide your comments in the chat, and we will come back to you by the end of the presentation. And we will make sure to leave ample time for the questions. Thank you so much. Great. Okay. And now let's move on to some examples, right? Here, we test the performance of AI detection tool to see to what extent they can identify human written versus machine written text, right? Here, UE made a very interesting choice of testing the United States Constitution. We, the people of the United States, in order to form a more perfect union, establish justice, ensure domestic tranquility, provide for the common defense, promote the general welfare, and secure the blessings of liberty to ourselves and our posterity, do all in and establish the Constitution for the United States of America, right? And the AI detection tool analyzed the text and suggests that there's only 12% chance for this text to be generated by AI. And hopefully this is correct, right? Because by the time that the Constitution was written, there were probably no AI algorithms. Right? However, notice that this sentence is probably long-winded, right? With and diverse structure, and it's easy for the machine to realize this is human written. But there could be some edge cases. For example, a lot of mathematical algorithms were written in a way that is very uniform, that is very coherent with a very predictable sentence structure. And this would be easily confusing a lot of AI detection tools. For example, here, a mathematical description about Pythagorean theorem can be mistakenly detected as AI written. Because it's very uniform, right? In order to determine the length of the side of a right angle triangle, algebraic techniques must be applied to rearrange the variable in such a way that the square of the hypotenuse is expressed as the sum of the square of the other two sides. You can read the rest, right? But you realize this Pythagorean theorem is written in a way that is very uniform and very much resemble an AI written text. And the machine actually classify there's 100% chance that this text is written by AI, but actually it is not. And then to verify this, UE simplified the language to make it sound casual using the following prompt. So if you want to get the length of a side in the right angle triangle, rearrange the variable so that the square of the hypotenuse is shown as the sum of squares of the other two sides. Doing this gives you an equation that can be solved by taking the square root of both sides, blah, blah, blah. And again, well, for this edge case, the AI algorithm still think there's a 100% chance that this is written by AI. And then Yi made a smart choice of asking ChatGPT to say this like a caveman, right? With no with very brute force language describing the theorem. To find side in big triangle with stick straight angle, make big line across hypotenuse, have square equal, add up squares of the stick-like size, take square roots for the answer, get side lengths you look for, old always true rule, Pythagorean theorem, seeing big lines across square always same as stick-like size square put together, right? So this is actually AI written, but mistakenly the AI algorithm detects only 26% the chance that this text is AI written, right? So AI detection tools can definitely make mistakes. Okay, so how reliable are those AI detectors, right? In terms of performance, no, AI detectors may work well with longer text, but may struggle with unpredictable AI outputs or edited text, right? So the chance of making mistakes really vary given different lengths and different contents of the text. So the overall accuracy, some of the premium tools that ask you to pay may suggest up to 84% of accuracy, but of course varied greatly by the content, while free tools usually offer around only 68%, right? So not that amazing. And so therefore, we would say the AI detectors may provide some helpful indications of AI-generated content, but shouldn't be the sole evidence, right? Because they are going to make both type 1 and type 2 error, both false positive and false negatives. Okay? And of course, we need to consider ongoing development because as AI evolves, those detection tools may continuously adapt, but also on the same time facing challenges in maintaining pace with new language models, because now many new language models tend to have the capacity to really mimicking human written text is almost impossible to identify. We'll talk about those aspects a little later. And now let's switch gear to the difference between AI detectors and the plagiarism checkers. They are related, but they are different. Right? So the AI detectors, as we introduced, are the tools that aims to identify AI-generated text by analyzing text characteristics without a database comparison. Right? On the other hand, the plagiarism checkers, those are the tools that may or may not use AI to detect copied text by comparing it against a database or a number of sources in order to identify the degree of similarity. Right? For example, Turnitin is mainly a tool for detecting plagiarism. So it has a vast database consisting of student papers, academic publications, web content such as website, blogs, news portals, public repositories, etc. Right? So it has a huge database to compare the text against. It also utilized fingerprinting technology to detect unique content patterns and paraphrasing. And of course, the database is up to constant updates, right, to maintain relevance and accuracy. So here I would say it is critical for us to be able to differentiate the AI detection tools versus the plagiarism checkers. Both may use AI technology, but the aim differ to some extent. Okay, so here is an example of a submission scanned by the Turnitin and with a similarity report. Okay, so many of our faculty and students have probably used Turnitin features, so this may not be you may all be familiar with this kind of tools. Right? So it gives you the extent to which a certain paragraph or sentence or part of a sentence overlap with existing content in the database. So the plagiarism checkers, on the other hand, have some limitations, right? So one is that it may mistakenly flag AI-generated text and is drawn from uncredited sources, right? Consider that more and more text now on the internet are generated by AI tools, large language models. If the data set used by plagiarism checkers include some of the AI-generated text, then it may flag AI-generated text as plagiarism, although, well, it is actually not plagiarism, not a copy of the existing AI-generated text, but maybe human written or maybe generated by AI algorithms. Okay. So this kind of mistakes or errors are more likely to happen with popular or general knowledge topics that are abundant on the internet, where less likely with more specialized topics that have been written about less. Okay. So if we consider the capacity of large language models in generating text, recently OpenAI announced that the capacity of their models alone can generate 10 times as many text as all the human beings can generate in a year. Right. And that is only OpenAI alone, not consider many other language models, right? So probably in the next 5 to 10 years, we will see an increase, a dramatic rise of AI-generated text that is going to dominate the internet. And if that is to happen, then it is unclear how the plagiarism checkers are able to check against the database if the database is primarily filled by AI-generated text. And another interesting technology is the Watermark. So in terms of the text generated by AI, some companies, AI companies such as OpenAI, are exploring a watermarking system for text generated by AI, for example, ChatGPT, to invisibly mark content. The technology is still under development. We don't know exactly the algorithm involved, but on the other hand, the images generated by, for example, DALL-E 3 by OpenAI have already carried watermark since February 2024, this year. The watermark technology is probably harder for text because it is uncertain and probably difficult to still carry the watermark when the text is under substantive editing. But for images, because of the vast number of pixels and the minor tweak of the pixel numbers, then it's potentially easier to carry the watermark even after you edit the image to some extent. So let's take a look of some of those technologies on image watermark embedding to prevent plagiarism or being able to differentiate AI versus human painting. Okay. So a lot of detection tools have been developed, for example, Deepware, Fake Catcher, and Illuminati. So Deepware scanned AI-specific artifacts. For example, you often notice that AI-generated images have inconsistencies in textures. They have some kind of unusual edges or distortions in images that are less likely to happen in real images. So Deepware utilized those artifacts to identify digital content. And Fake Catcher used a different algorithm. They try to analyze the subtle blood flow in visual pixels to differentiate real and synthetic faces. Okay, because the color of our vein on our faces and to be subtle, but usually the blood flow and vein color generated by AI images are not realistic. So the illuminati focused on identifying irregularities in lighting and shadows that are typical in AI-generated images. Right? But of course, the challenges ahead is that when the technology improved, manual detection will become increasingly difficult. And here is an interesting image generated by AI. The Prince Harry and William, they hug each other. But you will notice that this is the so-called double Harry portrait. Because usually, if a famous person's name was used as a term in the prompt by the AI, sometimes the AI will duplicate them. So you see that Harry actually, besides hugging William, sit at the back. Right? So this can be easily told that this image was generated by AI. But sometimes it's more subtle, right? There are a few clues that we can use to identify AI-generated images versus real painting. For example, non-circular pupil. So AI can't really do circles to some extent. So the albedo of the pupil is difficult to replicate, as you can see clearly. You can see. I'm not an artist. I can't really tell much of difference. But if you're a professional artist, you probably can tell subtle differences. The uninterrupted block of teeth, which is quite obvious. So this is called AI smiles. It can appear like a whole row of teeth was being kept in one action. And also the closing doesn't make sense. For example, the red bow here, the bow is red on the one side and with a plain color on the other side, which doesn't make sense. And if you also look closely, the sails and the rigging on the schooner is unlikely, right? So this is not a typical shape of a schooner. And this is an image that won the Sony World Photography Awards. And the author played a cheeky monkey, and he didn't announce, they didn't declare that this image was generated actually by AI. And when he won the award, he declared that, right? So if you look at clearly of this photo, not really a photo, but AI-generated image, the fingers have mismatched lengths and fingernails. And the unlikely shape, drip of the costume here, which defines fabric biases and no salvage to the sleeve. Okay. And also the pearly defined ears here. So those, and the eyes, there's a flat edge to the right iris, and the spark is wrong. So if you take a look closely, you probably can identify some clues to differentiate AI-generated image versus a human-generated image. Okay. But this really tells you how difficult it is, even to the eyes of the professionals. The judges, right? They still are able to identify this image actually was generated by AI rather by a human photographer. Right? So how the watermark is constructed in images. So it involved subtle pixel manipulation because the pixels are just floating numbers, right? And we know that for RGB image, for each pixel, it can take one of the 256 numbers of the pixel, 0 to 255, right? And usually there are three channels, red, green, and blue. And some very subtle changes in the floating number that are invisible to naked eyes can be used as a way to watermark the image. So for example, here with this sync ID, the users can add a watermark to the image, but this watermark is imperceptible to the human eye, but it can be detected by using AI algorithms. Okay? So this kind of manipulation is often done in a way that a pattern can be detected and also decoded by specialized AI software designed to recognize those watermarks. Okay. So here, for example, on the three of the images here, the right-hand side of the image is watermarked, where the left-hand side is watermarked, where the right-hand side is not. But can you tell the difference? No, I can't really tell, right? It is invisible, very much invisible to human eyes. But it is detectable by AI algorithms. And also the pixel changes are usually spread across the entire image. So even if you change part of the image, the watermark is still detectable, right? So those are the state-of-the-art ways that we can protect the copyright and also differentiate AI versus human-generated images. But well, on the other hand, the watermark technology in text is still under development because, well, we can utilize the vast number of pixel values to embed our AI detectable patterns, watermark in the image, but it's proved to be much harder for text, right? Because the text doesn't have a floating number, right? It is very limited in terms of choices. So even if you embed a watermark, that is invisible, not invisible, but not readable by a human being. But if you annotate the text, then it's much harder to maintain the watermark in the text. So now our team also developed our own AI detection tools, which use a different algorithm. So previous tools used mainly either some kind of statistical properties of a text or training AI language models to detect the AI generated text. But we use a different approach. The idea actually is pretty simple. We use the prompt, for example, if the faculty design a homework assignment, and then we use the assignment and utilizing large language models to generate variations of the answers to the assignment. And then we can compare student manually written assignments to the AI generated assignments, because both are going to cluster in their own multi-dimensional spaces. And we use the distances between the two clusters to identify AI generated text. So we achieved a very high AUC score of 0.99. So 99% of the time, we are able to identify AI generated text from human generated text. Although the algorithm is highly accurate, but it's computationally pretty heavy. Okay? So that is the downside of this AI detection algorithm that we developed. So if you're interested in that, we can send you the papers. Okay? And thanks to Eric, I see Eric here. He made a fantastic point that actually some of the AI detection tools are now available to trick the AI detection tools. Okay? If that ever makes sense, right? For example, one of the most popular customized GPT as in the GPT store is called AI Humanizer Pro. Okay? So it's popular because it claimed to be the best AI humanizer to help you get 100% human score. So humanize your AI generated content to bypass AI detection. Use our advanced humanizer to get past all AI detectors in the market. So basically, you are using AI detection tools. You are using AI algorithm to trick the AI detection tools so that you can get a pass, right? Another software which is quite popular is called Content at Scale AI. It has an advertisement, want undetectable AI content, then AI Humanizer has you covered. The AI Humanizer uses a proprietary mix of 3 AI engines, NLP, and semantic analysis algorithm to rewrite sentences and paraphrase paragraphs in a way that is so human-like that it bypasses even the toughest and the most accurate AI detection tools. Okay, so ironically, the content scale AI also have a designated AI detection tools. Okay, so that is really add to the controversy of those AI detection tools. And what are the main limitations of those AI detection tools that we started quite a number of them? First, it struggled to detect AI text that is extensively edited or paraphrased. Right? The accuracy would be very much lower if the AI text is edited or paraphrased. And the second, it really can't keep up with the rapidly outpacing detection method. A lot of those AI models, they are developing so rapidly that these AI detection tools have a difficulty to keep up with. And the detection accuracy varied across languages. Writing style is probably most accurate in English, but for short for other languages and writing styles. And of course, a lot of tools just give you, a lot of false positives and false negatives. So there's a great risk of incorrectly identifying AI-generated or human-written text, right? And it's create a lot of anxiety and maybe unfairness to students and to trainees, whose text were mistakenly considered as being AI written. And also, the AI detection tools have to balance between generalizability and specificity. Because some of the tools most of the tools are built for general tasks, but few are built for specific, targeted languages or domains. And also it adds to data privacy concerns, because a lot of time is our data that we submit to the tools are being used to train the model, are being used to fine-tune the algorithm. And also many of the tools demand computation, very heavy computational demand, and it consumes a lot of computational resources. And also, those tools are not exempt from potential biases, because if the data are biased in training those tools, and then those tools are going to create biased results. And of course, finally, is the user trust. To what extent we can convince the users, or should we really convince the users that tools are reliable and are necessary? And regarding future directions for the AI detection tools, we can really enhance the NLP models, the natural language processing models, which are foundation to those tools. And on the other hand, we should also not to forget the old-fashioned way that we detect plagiarism and detect text generation, which is the behavior analysis, right? Still today, I think this is probably the most reliable tool, although it doesn't really probably use any AI algorithms. That is based on your understanding of the students' performance and the way that we write things, right? Because believe it or not, the way we write things are very difficult to change, right? It is like its own watermark that is visible. So a lot of time, we can easily tell whether the text is written by a student or by others or by the machine just by analyzing, looking at the style of the writing. And cross-referencing sources, the tools might start incorporating cross-referencing functionalities to detect AI content, given we have a well-curated data set. And AI detection tools may continuously update their detection algorithms based on the new AI content-generated models and methods. And there are many other potential algorithms that we can try out, for example, expansion to different languages, integration with educational platforms, improvement in short text detection, improvement user interface, etc. But really, philosophically, what are beyond the binary detection? No, the key concept is that we should not limit ourselves to the binary thinking of this text is generated by AI and that text is generated by human being. The reality is much more profound, right? So first, we need to rethink the detection. acknowledging that probably a 90% AI generated score does not definitely indicate AI authorship, right? AI and human often collaborate, blending creativity and computational power. And the lines are becoming blurred over time. So as AI integration deepens, as we continue this concept of human-machine partnership, the cases of joint brainstorming by human AI highlight evolving nature of content generation, which might infer the future. So we also need to think about how we can redefine contribution. Future tools may need to assess the contents of AI involvement rather than merely detecting AI presence. So this really involves reorganizing the iterative process of human AI collaboration, where the ideas are refined collaboratively. And we need to move beyond the percentages, moving away from a simplistic percentage-based assessment to really understand the nuanced role of AI in content generation. And finally, we need to probably think about the evolving perspectives. So recently, the OpenAI discontinued the detection tool due to accuracy concerns, suggesting that the strict detection may not be the ultimate goal. The focus may shift towards how AI can enhance educational and creative process, acknowledging the multifaceted impact of AI generation. Okay, so that's all for today's talk, and you're welcome to browse through other learning materials that we have on our website and our training and my new book, etc. You'll get all of this through the presentation slides. But now let's open up to questions. I see that Brandon raised his hand, so why not unmute yourself and talk?
Hello. I'm just wondering, this seems pretty general, which I think is good, obviously. I've been in talks. I'm an engineering doctoral student here at WashU, and I've been in the boardrooms for this, basically, like AI tools and use and plagiarism and detection software with the engineering school itself. And basically, as engineering, we have said that the AI beast has been let out of the Pandora's box, and we can't really let it reel it back in. And so most, if not all, of our classes now are going to be essentially required to be AI. And so the reason is because our dean said that if we're going to create competitive engineers in the field, they need to be able to use AI because everybody else will be using AI. And so that logic makes sense, but I don't understand from this talk why it is important to differentiate between human and AI generated images, videos, and text if the world is moving to a place where AI is going to forever be integrated into our lives. And does it does it actually matter if the integrity or original work comes from a student or comes from a student's prompt from an AI? Because technically the student is able to know what to ask the AI to do. So it technically is original work.
Right,
so
exactly.
That's my question.
Yeah, thank you so much for the question. Exactly, you hit the point. And actually that is the last few slides was about, right? So we need to think beyond the boundary detection. The detection still have a lot of usefulness. For example, we as faculty, we try to motivate students to exercise these critical thinking skills and solve the problem by themselves rather than relying on AI tools. And in my machine and deep learning courses, occasionally I would see some students over rely on AI tools to craft their homework assignments answers, and without fully comprehending the coursework and the required tasks. So that is something we want to avoid. But on the other hand, you are exactly right to the point that we are probably entering a stage of human-machine partnership, and the line is becoming more and more blurred. Is on the one hand harder for the AI detection tools to detect on the philosophical side, to what extent that's going to be useful, right? If we human being and machines are collaborating, in a deeper fashion or over time. And recently there's some debate over in the court regarding the copyright issues, right? What percentage of the text is generated by AI versus human being? That should be copyrighted. And it's really hard to provide a percentage even, right? Consider that you change part of the text, the AI changes, and you change it again. Is this really AI contributing, or is you contributing, right? Even no, we really cannot even classify word by word which is created by AI, which is created by human being, and not to say the entire creativity, right? Because to a larger extent, we are using AI as a tool to help us being more creative, and we are often inspired by AI, as we invent new things, right? So it is not a question that we can answer in this talk, but hopefully we give you enough food for thoughts, so we can learn more and we can study more about this very controversial but very interesting and timely topic.
Thank you.
Great. Yeah, thank you. And any other questions? Sorry, I was not able to screen through all the questions. But thank you, Eric, for helping me answer many of the questions. So yeah, if you have any questions, just feel free to unmute yourself and talk. And I'm looking at scrolling the question here. So the Eric asked, was turned in a vast repo of students submitted work used to train ChatGPT and other LLMs. This is a good question, but the short answer is I don't know. A lot of time is the company doesn't declare how they're going to use the data and what kind of arrangement turned in or other detection tools, or companies collaborate with other institutes. It's very much institutional knowledge, and they seldom declare that because they are also sometimes afraid of being sued for illegally or without acknowledgement using user data. Right? It's very much a black box.
Yeah.
Yeah,
Oh,
go ahead.
I had a follow-up to that question. I think about you were saying large language models, and I replied to this message, but I don't think that our repository of things at WashU are used to train ChatGPT or anything, to bypass Turnitin or anything like that. The thing is, like, as a student at WashU, before I was a doctoral student, I was an undergraduate student in engineering, and there is this thing that exists, and it's called well, I don't know what it's called. Actually, I do. I'm just not going to say it. It's like a kind of like a my professor calls it I guess let's say it's a repository of all of the exams, homeworks, projects, and syllabi of all courses in engineering. So the students have access to those kinds of things. It's invite only, obviously, but they have kinds of things. I know that some professors are on it just to make sure, like, things are being done ethically, of course. But I think that engineers at WashU, as well as engineers elsewhere, so I've heard and talked with them, understand that in the real world, or even in academia, even like my path at academia, you're never going to have to not use AI, internet, Google, calculators, like all of those things. Like, we've talked about how AI is similar to a calculator or the iPhone, right? Like, people said you're never going to have a calculator in your pocket, right, at all times. And that's what I was told in elementary school. And now nobody knows how to do their times tables, right? Because they don't need to. So it is a weird question, and I'm glad you're, as conducting these talks, because I think people need to know about it, especially professors, since think that the engineering professors like don't want to get outsmarted by their students, but always get outsmarted by the students because these students are the ones creating the AI and they're not professors creating AI. It's these students that drop out and like create the stuff, right? So it's kind of it's unfortunate, I think, from a professor perspective in engineering because
Yeah, yeah.
they get outsmarted, but it is what it is.
Well, I don't think this is unfortunate. I think it's very fortunate that we all hope our students can outsmart us. I think that is the how the higher education should aim for. But thank you so much, Brandon. Thank for everyone for attending this talk. And stay tuned. We will have the next talk in 2 or 3 weeks. See you, everyone. Bye.